Hey class, today I will be teaching you about concrete and abstract syntax. First, let's do some review of syntax and semantics. Recall that syntax is the rules that define what is correct code for a programming language, and semantics is the meaning of the code. I like to remember this by remembering that syntax is symbols and semantics is meaning. Now, we have a short quiz on the difference between syntax and semantics. I encourage you to pause the video to try this out for yourself. There are multiple ways to fill out this table. Here's one sample solution that I came up with. So, what is concrete syntax? Concrete syntax is what the programmer writes or what is displayed. It is specified by a grammar and contains the rules to resolve ambiguity, for example, order of operations. Here is an example of concrete syntax. We see that we have a keyword, an identifier, and punctuation. Here's a more involved example. Let's say I want to write a function that takes in two integers, a and b, and returns the sum. What is some concrete syntax I can write to accomplish this? Here, we can see three completely different concrete syntaxes in Python, Java, and Haskell that all have the same semantic meaning. Now let's go over abstract syntax. Abstract syntax is the representation of the code as a data structure, which is usually a tree. In fact, trees are so common that sometimes we just refer to the abstract syntax representation as an abstract syntax tree. Abstract syntax discards exact keywords and punctuation, like parentheses, for example. Whereas concrete syntax might require rules to resolve ambiguity, there is no ambiguity in abstract syntax due to the structure of the data type. Here, I have some concrete syntax for adding two integers a and b in Python, Java, and Haskell. Let's turn that into an abstract syntax tree. You'll notice that while these three lines of code have completely different concrete syntaxes, they have the same abstract syntax tree. Here's another example where we add 1 to 2 and then we add the result of that to 3. And here is the resulting abstract syntax tree. Notice that the structure of the tree makes it clear that we are adding 1 and 2 first, and then we add that sum to 3. The process of going from concrete syntax to abstract syntax is called parsing. The reverse process of going from abstract syntax to concrete syntax is called pretty printing. Let's check your understanding. What is the abstract syntax for the following concrete syntaxes? I encourage you to pause the video to try this out for yourself. Here's the tree that I came up with. Notice that the structure of the tree makes it clear that we multiply 4 and 10 first, and then add 2. Here's another exercise. What are some concrete syntaxes for this abstract syntax? Once again, I encourage you to pause the video to try this out for yourself. There are many concrete syntaxes you could have come up with. Here are some examples that I came up with. The last thing I want to go over is why should you care about concrete syntax and abstract syntax? I want to show you with an example. How would you like to represent the sum of 2 and 4? First, let's draw the abstract syntax tree. Now, let's pick a concrete syntax. Do you like parentheses? Use parentheses. Don't like parentheses? Don't use parentheses. Don't like words? Don't use words. The key idea here is that there are many ways to represent the same abstract syntax, so you can choose whatever style of concrete syntax you want. I want to show you just how creative this can get. Shakespeare programming language does exactly what you think it does. It makes code look like Shakespeare plays. Some programming languages don't even use words. Before modern computers, people programmed by punching holes in these pieces of paper called punch cards. This is also an example of concrete syntax. My last example is Scratch, which is a popular website aimed at teaching kids how to code. They used block-based programming, which is also an example of concrete syntax. The point I want to emphasize here is that because we can convey the same abstract syntax with all sorts of concrete syntax, you can use your imagination to design whatever concrete syntax you like. The second reason why you should care about concrete syntax and abstract syntax is that understanding these two concepts is vital to understanding parsing, which is a part of almost every programming language. Let's summarize what we've learned today. First, we reviewed the difference between syntax and semantics, remembering that syntax is symbols and semantics is meaning. Then, we learned that concrete syntax is what the programmer writes or what is displayed. We also learned that abstract syntax is the representation of the code as a data structure, which is usually a tree. We learned that parsing is the process of going from concrete syntax to abstract syntax, and pretty printing is the process of going from abstract syntax to concrete syntax. Lastly, we learned that we can make all sorts of concrete syntaxes, and that understanding these concepts of concrete and abstract syntax is important for understanding parsing, which is an important part of most programming languages. Thank you so much for watching. This is your CS Professor of Fun.